All right, let's dive into kinematics. It's one of those physics topics where your gut feeling can totally trick you. Okay, here's a classic question. Your first thought might be to just average the two speeds, but is it that simple?
If you said 20, you've just walked right into the most common trap. Don't sweat it though, almost everyone does.
So, to avoid these traps, we gotta be super precise with our language, and that starts with the very basics. First up, scalars versus vectors. One just tells you how much, the other tells you how much and which way. This leads us to distance versus displacement. Think of distance as your whole journey. Displacement is the shortcut back home. And that brings us to the big one, speed versus velocity. Nailing this difference is the key to our cyclist problem. All right, back to the cyclist. So why isn't the average 20? It's all about how much time each part of the trip takes. See, the trap is averaging the speeds. That shortcut completely ignores that you spend way more time going slow. The right way uses the core physics formula. Average speed equals total distance over total time. Let's plug it in. So the total distance is 2d, and total time is d over 10 plus d over 30. The d's cancel out, and bam, 15 kph. Okay, next trap. This one sounds totally logical, but in physics, it's actually false. Check this out. The key here is that it's only stopped for a split second. Literally, just an instant. Think about a ball you throw up. At its very peak, its velocity is 0, but gravity is still pulling it down. So how do you actually solve problems with constant acceleration? Well, physicists have a special toolkit just for this. They're called the SUVAT equations. They're super powerful, but they come with one huge, non-negotiable rule. You can only use them when acceleration is constant. If it changes, like in a car crash, you can't touch them. Each equation links 4 of the 5 variables, so if you know any 3, you can always figure out the rest.
A classic example is projectile motion. SUVAT lets us split the horizontal and vertical movements and analyze them separately.
Okay, let's wrap with one last mind-bending idea in kinematics. Turns out your point of view changes everything. It's called relative motion. An object's velocity is always measured with respect to something else. Always. So let's do a quick recap of the traps to avoid so you can absolutely crush your next physics problem. And to leave you with a thought, from your seat on that train, the trees are moving. It's all relative.